Okay, welcome back to my channel. We are going to get started on the garage door assignments or programs or exercises, whatever you want to call them. I'm not going to go over really these little I guess training exercises in between the like assignments. These are for you to play with and to learn more about. With the exception of, on this case in particular, we are going to talk about latches and seal-in circuits because it is brought up on the garage door. So this is latching circuits, right? So basically, you tell it to turn on, it comes on, and it stays on until you literally tell it to come off, and then it unlatches and it goes off. Um, Seal-in circuits are going to be your more commonly used circuit types, and this is going to be for like keeping a motor on or whatever, because most of your push buttons, like your start buttons and stuff, and even your stop buttons, with the exception of an e-stop, they're going to be momentary press buttons, right? So you press it, it makes completes the circuit, sends the electricity to the input channel of the PLC, lets it know that it's satisfied, and then when you release it, the electricity stops flowing. But you need it to keep going, right? So basically, um, the stop. So your start buttons are going to be normally open push buttons. Your stops are going to be normally closed, which means when you're not doing anything physically to change the state that it's in, that it's going to be open in a normal state. So that means the electrical circuit will be open, so no electricity will be running through it. For your stop, it's going to be normally closed, which means it'll be normally closed. So there will be electricity able to flow through the circuit until you push the button, and then it will open up. So that's what normally open, normally closed means. And so let's walk through the seal-in circuit real quick. So your stop button is going to be normally closed, so it's going to be satisfied, right? This input will be satisfied because electricity will be running through the push button itself and into the channel until you hit the button. And then when you hit your start button, you're going to activate, you're going to satisfy the circuit, so the electricity starts going through it. So this will activate this bit, and then your lamp will come on. And when this lamp comes on, it will turn on this bit because, as you can see, they're the same channel. They're the same output. It's just this is the output bit, and this is like an instruction bit, but here it's like more of an observation bit. But so when this becomes true, then this will become true as well. And then, so basically you'll have electricity coming from over here, going through your stop button, coming down through this bit that verifies, that indicates that the lamp is on, and then that will keep the lamp on, and then the electricity will go out essentially to neutral. So this is referred to as a seal-in bit. I'm not sure why they don't refer to it like that in this it's these instructions or this training system. I'm not sure why they don't do that, but these are latching bits, or I'm sorry, this is a latching circuit using latching bits, and then this is a seal-in circuit, right? So that's that. So let's go ahead and jump down to the garage door. The garage door here. I'm not going to walk through this. You can read it, but basically it's just telling you, look here, and this is how you read, how we have everything set up. Exercise 1, let's read through this from 1 real quick. So in this exercise, we want you to apply your knowledge of relay logic instructions to design a program which will control the ProSim 2 door. The door system includes a reversible motor, a pair of limit switches, and a control panel, all connected to your PLC. The program you create will monitor and control this equipment while adhering to the following criteria. Okay, so in this exercise, the open and close push buttons will be used to control the movement of the door. movement will not be maintained when either switch is released, and therefore the stop switch is neither required nor used in this exercise. However, all other available inputs and outputs are employed in this exercise. Okay, so what they're saying is, basically at this point in time, we're not going to use latching or sealing. It's literally you hold the button in, it runs, you let go of it, it doesn't run anymore. Simple enough. So pressing the open switch will cause the door to move upwards, open, if not already fully open. The opening operation will continue as long as the switch is held down. If the switch is released, or if limit switch LS1 opens, the door movement will halt immediately. And then, so that makes sense, right? Like I just said, pressing the close switch, so vice versa for close, pressing the close switch will close the door or cause the door to move down. Close, if not already fully closed, the closing operation will continue as long as the switch is held down. If the switch is released, or if limit switch LS2 closes, the door movement will halt immediately. Makes sense, same thing, right? It's what we have said a few times now. So next, if the door is already fully open, pressing the open switch will not energize the motor. And if the door is already fully closed, pressing the close switch will not energize the motor. All right, let's talk about that for a minute. So why is that? So two main reasons why you would want to do those limits. So basically, this would be an interlock, right? A safety interlock. So an interlock just means that there is a condition there that like if this is happening, then I won't allow this to happen if this other thing is happening. So kind of like I mean, you can kind of do it, but a kind of simple explanation is like, the old phrase like or the old thing of like patting your head and rubbing your belly at the same time in a certain motion. Like that can be okay. That was a bad example. But anyways, yeah, it's like when you're making fun of someone that you like can't lock and chew gum at the same time. Kind of same thing, right? So basically, what we're doing here, though, why you would want this interlock, is like say on the open switch, say you have the rails that your wheels go or the tracks that the wheels go on for the garage door. Well, if there's no like end caps, and you keep pulling, well, those wheels can pop off the track, and then when you go to close it, they won't line up, and so that could put you in a real world of hurt. Or like on the flip side, if there are caps, then you're still tell it to open, then it's going to sit there and pull amps and amps, and so the motor's going to work harder and harder, which is going to increase the amps. Increasing the amps is, more current. More current is more heat. More heat on the wire is bad. That will cause a fire. And literally, that's how electric heaters are. That's the whole principle of an electric heater is you have a wire and you send electricity through it and it gets hot. And then you blow air across that to blow the air out. And now you have a heater. That's literally what a heater is. So, you want to use these switches to tell the motor to stop. So essentially you don't burn up your motor, right? You don't cause a fire or, in a perfect world, assuming everything is engineered properly, there would be circuit breakers so that you wouldn't, burn up your motor. It would detect a certain amperage draw, and then it would either, trip your breaker, or if you have fuses, it would blow your fuse. But just in case, you don't want to trip your breaker every time just because someone held the button too long. Okay? So, in the other direction, if the door is fully closed, pressing the close switch does not energize the motor. Same thing. You don't want to burn out the motor. Under no circumstances will both motor windings be energized at the same time. So same thing, right? Like if you are telling it to open and if you're shooting electricity through your motor to both open and close at the same time, you can burn up your motor, or you might have a situation where it sits there and pulses back and forth, which would be bad for the motor. One way or another, it's going to cause damage. Moving on. So the open lamp will illuminate if the door is fully open position. The shut lamp will illuminate if the door is in the fully closed position. Pretty self-explanatory, right? Like, well, those limit switches are there to literally light up the lamp. That's what we're going to do. So next, it is your responsibility to fully design, document, debug, and test your program. Avoid the use of OTL or OTU latching instructions and make a concerted effort to minimize the number of wrongs employed. So, yeah, we don't want to use latching because, like I said, latching, we want to use sparingly. Latching is, it has its times to be used, but they can be dangerous. So, like in this instance, or in this scenario, right, with the garage door, if we use a latch and say we tell it to open, right, and something happens, and say we're in a troubleshooting situation, and instead of someone hitting the stop button, and it's latched, we hit the open button, and instead of someone hitting the stop button to unlatch it, they just kill power to a disconnect, right? Well, the PLC program doesn't know that it's not running anymore, right? Or that it's not supposed to run anymore. So when you power it back up, that motor is automatically it's receiving the signal to open. So it's going to do that. So it's going to start moving. So it could be dangerous, people being in the wrong place, not being aware, that you're powering up. Or it might be a situation, there's might be some other scenario where it might cause, damage to hardware. So, you just don't want to use latches unless you need to. And then this last paragraph, ensure that you have made effective use of both instruction and run comments to clearly document your program. All IO components referenced with your program should be clearly labeled, and run comments should be employed to add additional clarity as required. So this is a good point, right? This is a best practice thing. So in the industry, we have things, kind of like standards or whatever, but it's best practice. Like, you don't have to do it, but it's a really good idea to do it. In this case in particular, the comments are notes. They're literally notes, right? So you're leaving notes there for the person behind you. And what I've come to find out is often I'm the person that's coming behind me. And it's usually months later. And I've done a variety of other things. So I'm not in the same mindset I was as when I was programming. And, the comments help me know what's going on in that particular part of the code without having to reverse engineer stuff and go look throughout all the rest of the code of how everything's interacting and stuff. There'll be like a comment right there. And then so in the documenting or naming your instructions, your bits, essentially, you want to make or use a logical name for your bits. That way because there's no reason to have to jump over to your drawings to see what each input and output and, which float and whatever is actually doing. Actually it's only your inputs and outputs that would be on the prints. All your internal bits for the program, PLC, they won't even be on there. So give it a logical name. That way you can look at it and be like, oh, okay, well, that's what this is being used for. It just makes sense, right? You got to make it easier for yourself and everyone coming behind you. So let's go ahead and get started on this. So let's open up the door simulator. And then if we select that guy, let's give ourselves a couple of runs to get started with. So then to get started, we can pick, really on this, there's two main points of it, right? There's the light control and then there's the motor control. And, it's really a tomato, which do you want to start with? doesn't matter in this case. There's more than one way to skin a cat. I mean, this was pretty direct, but it's literally like which one comes first. This one, it doesn't matter. Let's go ahead and start with motor control, just because, that's what I want to do. So motor control, and then we'll go semicolon, and let's start with open because the garage door is closed. So open seems the most logical. So, we'll say, motor control open, simple enough. And then to open it, let's give ourselves one of these bits, one of these bits, one of these bits. We'll probably need an extra one of these. So let's move that over here. So the first thing we're going to do to open the door is we're going to push our push button, right, for open. So that's going to be I1/0. So actually, real quick, this lettering and numbering system, let's go over that real quick. So I is for input, right? O is for output. And then you'll have, like as you go on the career path, you'll have AI for analog input and AO for analog output. Those are the basics that cover that stuff. And then you have your first number there is going to be which slot in the module or card lineup is it. So and then the last set of numbers there are your channel on each card or each module. So let's break down that a little bit more. If we look at this picture over here of this PLC rack, right? So this dark gray part is the power supply. So that's where you're going to be. That is where you're going to land your wires. Okay. So, and there might be like an SD card in there for memory in case like things go wrong. And you can put your memory, your program in there on the newer systems. You might use that for, or you would use that for your like your data tables and your tags and stuff like that on your newer systems. But so like that's the like kind of like the mother, or not the mother, but the yeah, it's like the motherboard. It's like where the power distribution goes out across. That's where your power comes in and where it goes out. So that's not counted in this numbering system. With Allen Bradley, your numbering starts with 0, right? So it'll be 0, 1, 2, 3, etc. This first slot here is going to be slot 0. And in this case, in this slot, we have the controller, right? So the controller is the essentially the computer or the brain, right? So that's where the program lives. That's where all the decisions are made. Okay. So that's that's slot 0. And the next slot, you have an input card or an input module, right? So that's why our inputs are 1. And then our outputs are 2, because next to that is an output module. So it's output 2. And then the next one, I mean, it doesn't pertain to us. It looks like it's something else, like maybe some kind of a network card or something. But it could be anything. It could be another input card. So like if it was an input card to access the points on that card, it would be semicolon 3/whatever channel. Okay. So on and so forth. So, and then on your input and output modules on Allen Bradley, they tend to have 16 channels, right? Because it's a 16-bit processor. And, but again, the numbering system starts with 0. So it's going to be 0 to 15. Just to keep that in mind. Let me take this from. Okay. So, that is how the, lettering and numbering structure works with PLCs, particularly Allen Bradley. Let me get back to this. So we want to, give this bit a name, and this is going to be our open button. And what we want to make sure is not happening is we want to make sure our close button is not being pushed, right? So We are close button. And let's see then what else. Limit switch, right? So the open limit switch, we want to make sure that that is not being made. So that's going to be I1/3, and that is going to be our that's one open. And then our when we push the button, what do we want? We want to make the lever go up. It's going to be out to 0. And we're going to call it this. Nope. Delete that. We are going to name that lever up. Let's see. And then really to save some time, let's go ahead and copy that wrong. Let's paste it below. Let's edit the comment. And so let's just switch this guy, and we want to switch that guy, and we want to change this to our LS2. We'll switch, and actually we will want to change what we're looking for there, and we're going to change this, and that will be motor down. Okay, so that should be our motor control, and then next would be our lights, right? So let's go ahead and let's just work our way down from how they're listed on the control panel there. And we're going to say a jar light. Lights when the door is not fully open or shut, actually. That's good. And then what we want is this guy. Piece of instruction. This guy. Piece. Great. It really doesn't matter which is which, but let's go ahead and keep them in order and how they appear here. Let's see. And then we want to copy this. Copy or paste it to the right. And our jar light is output to 2. And that is a jar. And then let's copy this and paste it below. Let's do that twice. And let's change our comments. So we already did a jar light. Let's do open, and is fully open. So yeah, you're gonna get used to copying and pasting because when you're working on a huge program, just writing the same thing over and over again, it takes up a lot of time, and it is just annoying. So you'll get used to doing what I'm doing here basically. So no, it's like eliminates when Chrome goes dynamite. Let's actually delete, and this should be what 4, and it should be that. Okay. Let's see here. I think that's it. All right. So let's go ahead and delete this extra rung. And yeah, that should be it. Let's go ahead and download. I have increased the scan time because this moves painfully slow at the normal 10 scans per second. In the real world, you cannot adjust your scan time. What you would do in this case is you would adjust this that output frequency of your VFD, which is a variable frequency drive. And a VFD is essentially, you can think of it as your gas pedal on your car, right? So when it comes to electric motors, if you just wire them straight up to like a switch, they're called contactors, but it would be either off or 100% speed of the motor, right? Well, with the VFD, what that does is it allows you to run it at any speed in between those, and technically you can even go over full speed, but that's a different subject matter for a different day. Okay, so I believe we already ran this thing, and yeah. So as you can see, we are something's not right because we have our limit switch is showing open. And what is not right with that is we have our what we're looking for is reverse. So let's go ahead and put it back in program. Let's change that and let's change that. Okay. And then let's try this again. Let's download it. All right. So now we are shut, right? That is correct. So let's open. Good. We let go of it. It stops. We hold the open button and it should go until it hits that limit switch and the motor stops. That's good. So let's try to close. Good. Let go of it. We're good. And we continue until we hit the limit switch and it works. So that works just fine. That's exactly what the customer is looking for here. So just to show you what would happen, let's, if we didn't have these limit switches here on motor control, let's go ahead and delete that guy. Let's download it. And then we'll put it back in run mode now. So we're already all the way closed. And so if we tell it to keep closing, as you can see, the motor bursts into flames. That would be bad. All right. So that's why we put that permissive in there. Okay. So, yeah. So let's go back to program, copy and paste and download. And double check, and yeah, we're good. All right, so that is the exercise 1 on the garage door. Thank you for joining me, and I'll see you on the next one.